In this video, we're going to talk about adding and subtracting rational expressions that have unlike denominators. So first thing we want to do with this type of problem is to factor each denominator. Because once we've listed out each factor of each denominator, we're going to be able to match them and figure out what the lowest common denominator is. Once we know our lowest common denominator, we can make the denominators match. So let's take a look at an example here where we're looking at just finding the lowest common denominator. So 8 over x squared minus 2x minus 3 and 3x over x squared plus 4x is 3 clearly have unlike denominators. So we're going to rewrite the denominator in factored format. So x squared minus 2x minus 3 can be rewritten as x plus 1 times x minus 3. And x squared plus 4x plus 3 can be written as x plus 1 times x plus 3. Now notice that we've written this vertically so we can see what aligns. Because x plus 1, for example, gets repeated, but we only carry it down once. Okay, then x minus 3 is a unique factor, so we carry that one down. And x plus 3 is also a unique factor, so we carry that one down. Okay, so now we can see that our lowest common denominator is x plus 1 times x minus 3 times x plus 3. So we can write that out as the product of the three factors. Now, in this case, we now want to find a way to rewrite each rational expression so that it has the lowest common denominator. So again, notice that you will want to have each denominator completely factored. So if you've written one factored and the other one not, just remember to go back and factor the other one. And remember that since our lowest common denominator was x plus 1, x minus 3, x plus 3, we want to find which part of that is missing from each denominator. So for example, in our first fraction, we are missing x plus 3. So we're going to multiply the denominator by that. But whatever you do to one part of the fraction, you have to do to the other. So if you multiply by x plus 3 on the bottom, you multiply by x plus 3 on the top. Similarly, if we look at our second fraction, it didn't have the x minus 3 from our list. So we multiply by that on bottom and on top. Now, we do simplify the numerators at this point. We do not multiply out the denominators, okay? But you do distribute out the 8 in the first fraction, and you multiply through by 3x in the second fraction. Now, when we are doing these, a lot of times there's going to be other steps. So just notice that right now that we're talking about is kind of the first part here is how to find the lowest common denominator and make two fractions have that matching denominator. So let's take a look at this example. 2 over x squared minus x minus 12 and 1 over x squared minus 16. We want to factor out the denominator of the first fraction. So to do that, we're going to do what two numbers multiply to negative 12 and add to negative 1. That's going to be x minus 4 and x plus 3. Similarly, when we factor out the denominator of the second fraction, x squared minus 16 is a difference of squares. So it's really x minus 4, x plus 4. We're going to write out our factors vertically, and we're going to find out what's missing. So notice that our lowest common denominator is x minus 4, x plus 4, and x plus 3 once we've written them out, okay? Because we have x minus 4, those are repeated, x plus 3 is unique, x plus 4 is unique. Now, when we look at our first fraction, we can see that that x plus 4 is what was missing. So that's what we'll multiply on top and bottom. In the second fraction, we are missing the x plus 3, so we'll multiply that on top and bottom. Then we distribute anything in the numerator, and that will make the numerators 2x plus 8 and x plus 3, respectively. Notice that I leave the denominators in factored form. All right, so let's actually apply that to an addition or subtraction problem. So if you have something that already has a common denominator, great. Add the numerators, combine like terms, simplify, etc. If they aren't like denominators, you're going to find the lowest common denominator like we just did and change each of the fractions to have that denominator. Then you'll add them together, combine like terms, and simplify, yada, yada, yada. All right, so let's try one. Let's look at 3 over x minus 3 plus 2 over x minus 2. Well, first of all, both denominators are completely factored already. So that's great. Awesome. They do not match though. So we have to find a lowest common denominator. So notice here that we have x minus 3 from the first fraction and x minus 2 from the second fraction. Those are both unique factors, so we carry them down. And so our lowest common denominator is x minus 3 times x minus 2. Now we have to identify what was missing in the first fraction. Well, I already have an x minus 3 there, so I'm going to multiply by x minus 2 on top and bottom. Similarly, in the second fraction, I'm going to multiply by x minus 3 on top and bottom. Ta-da! Now I want to distribute my 3 and distribute my 2. That's going to give me 3x minus 6 and 2x minus 6 in the numerators. Now my denominators match, so I am going to combine the numerators. So it's addition. So I'm going to write it as 3x minus 6 plus 2x minus 6. And then I can combine like terms. 3x is 2x is 5x, and negative 6 plus negative 6 is negative 12. So 5x minus 12 over x minus 3, x minus 2 is our final answer because it cannot be simplified anymore. 5x minus 12 is not factorable. All right, see, that wasn't so bad. So let's try another one. Let's try adding 2n over n squared minus 3n minus 10 plus 6 over n squared plus 5n plus 6. We can tell they do not have a common denominator, so we want to go and find the least common denominator, or the lowest common denominator. To do that, again, we're going to factor the denominators. N squared minus 3n minus 10 can factor out to be n minus 5, n plus 2. N squared plus 5n plus 6 is n plus 2 times n plus 3. All right, so you'll notice that they didn't write this properly vertically, but that's okay. You'll get used to it, and you'll just be able to do this really fast as well. So notice that n plus 2 is repeated, so we only carry that down once. But n minus 5 is a unique factor, and n plus 3 is a unique factor, so we carry those down once each as well. So our lowest common denominator is n minus 5, n plus 2, n plus 3. So notice that we're going to rewrite each of our fractions where the denominator is in its factored form, and then we're going to multiply by the missing piece. So our first fraction's denominator had n minus 5 and n plus 2, but it didn't have n plus 3. So we're going to multiply n plus 3 on top and bottom. The second fraction, when it was factored, became n plus 2 times n plus 3, which means that it was missing the n minus 5. So we multiply that on top and bottom. We then want to distribute the 2n and distribute the 6. And that's going to give us 2n squared plus 6n in the first fraction and 6n minus 30 in the second fraction. Now this is addition, so I want to go ahead and add the numerators straight across. Notice that, again, the denominator stays the same. And we can combine the like terms in the numerator, which in this case are 6n and 6n to give us 12n. But this is factorable. We're going to start by pulling out, We're going to start by pulling out the 2 in the numerator. Okay. N squared plus 6n minus 15. All right, and then we're going to check and see, does the numerator factor anymore? And it does. All right, n squared plus 6n, that should be minus 15, and it's really hard to read. Minus 15, so actually, no, it doesn't factor anymore. Sorry, that was a handwriting issue. So at this point, we say, okay, I guess we're done, but always double check. Don't assume that it can't be factored anymore. All right, now let's move on to the next problem. In this one, we have 8y over y squared minus 16 minus 4 over y minus 4. So this one's subtraction. Does that make it any different? Well, only barely, because we're going to, again, start by identifying, is there a common denominator? No. So we want to find the lowest common denominator. Y squared minus 16 can be factored to be y minus 4 times y plus 4. And y minus 4 is not factorable, so it just stays y minus 4. Notice that y minus 4 is a repeated factor, so we carry that down, and y plus 4 is a unique factor, so we carry that down once. So our lowest common denominator is y minus 4 times y plus 4. So when we look at our first fraction, it's already good to go. But the second fraction is missing the y plus 4, so we will multiply that on top and bottom. We'll then want to go ahead and distribute our 4 in the numerator of the second fraction. Now we have 8y over y minus 4, y plus 4, minus 4y plus 16 over y minus 4, y plus 4. We now want to subtract the numerators. Make sure to put your second numerator in parentheses so that when you subtract, you remember to distribute that negative, which is why it becomes negative 4y minus 16. When we combine like terms, we get 4y minus 16 in the numerator, which we can pull a 4 out of, all right? When we do that, you'll notice that y minus 4 is on top and on bottom, so we can cancel those, leaving us with 4 on top and y plus 4 on the bottom. So that is how you're adding and subtracting rational expressions, even if they don't have a common denominator.